In this video, we will learn logistic regression. So let's read the data file, and I'm going to place the Excel reader node on the canvas here, and then I will set it up to open the data file. The file is on-time delivery dataset, which has these variables, as you can see here. So we have on-time delivery rate, we have the average lead time, order volume, production utilization, region, and finally, this is the outcome variable, whether the supplier is a partner or not. So we have two outcomes here, yes and no. Yes, if the supplier is likely to be a partner, and no, if they are not likely to be a partner based upon these independent variables. Let's add in the node for logistic regression learner. So we are going to add the logistic regression learner node because we are going to learn the logistic regression model from this particular data. So let's set up this node. My target column is partnership. My reference category here has been selected to be no. So that means the probabilities that are going to be predicted for partner is equal to yes. Because remember, the reference category, this output is not shown in the table. The reference is not shown in the table. So the outcome which is going to be predicted is for the other category, which is partnership is equal to yes. I'm going to select the solver as iteratively reweighted least squares method. I will remove the serial number column, and I'm going to use all other variables: on-time delivery rate, lead time, order volume, production utilization, and region, which was a categorical variable in my analysis. And let's click OK. And then let's execute the node. And we can see that the output is there. Let's go down here and look at the coefficients and statistics. So we can see that these here are the coefficients of these variables. And we know how to interpret these coefficients. We will have to find the odds first, which is like e raised to power these coefficients gives us the odds values, which we can then interpret. So let's do that, and I'm going to send this data to a math node, a math formula node, because I want to convert those coefficients to odds. So I will put a math formula node, and in the setup, you will see that these are the different functions which are available. And I'm interested in this function exp and within brackets x, which is the exponential function. So whatever I pass on to this function as the variable x, that will be raised to, e will be raised to that power. So let's double click. So we can see that exp comes here. Now I want to calculate e raised to power the coefficient. So I will break the coefficient here by just simply double clicking on coefficient. And now you can see that I have e raised to power the coefficient, which will be appended as a new column in my data set, and let's name that column as odds and simply click OK. And when I execute this node, I can see that down here that another column has been added to the data set, which is odds. Let's apply a column filter node as well, so that I can only look at the columns I'm interested in, and I will remove all other columns. So I'm going to remove everything. I will just bring in the variable name, the coefficient value, and then the odds value. And that is only the three variables I'm interested to see in the output. And let's execute, and then let's open the table. So here we are. On-time delivery rate, this is the value of the coefficient, and this is the value of the odds. So e raised to power 0.175 will give me 1.191. So we could simply say that as on-time delivery rate increases by 1%, the odds of a supplier being a partner will be multiplied by 1.191. This is how we could interpret these different variables. Okay, let's run another variant of the logistic regression model, but this time let's partition our data set into two. Let's divide our data set into test and train. Training set will consist of the rows which will be used to build the logistic regression model, and the test rows will be used to test the model. So let's set it up. So I'm going to leave the partitioning as 70-30. 70% of the data will go for training, 30% remaining will go for testing. Let's do a stratified sampling based on the partnership column, which is the outcome column. Stratified sampling here means that whatever the ratio of partnership, yes or no, in the original data will also be preserved in the training set and in the test set. So, for example, if my data originally had 80% yes and 20% no, so those 80-20 yes no will be preserved in both partitions, training and testing, if I go for a stratified sampling. So let's click OK and let's execute this. So now I have, you can see these two output connectors here. One is the first partition, and then we have the second partition. So the first partition, as you can see, has 35 rows, and the second partition has 15 rows. So let's send the first partition to build the logistic regression model. So logistic regression learning, the same settings that we had earlier. So I'm including all variables other than the serial number, and then execute, and the model has been built. And now I'm going to set the model for predictions. So now I'm going to use the logistic regression predictor node, which will use the model that I just built. The model has been passed using that first connector. Now this predictor node needs the data. So the data is now going to come from the partitioning node. Remember the second partition, which was the test set, which contained 15 rows. And these are the rows which were not used to build the model. So I'm going to be testing that model on this unseen data. So if you look at the settings for the predictor, you see it is going to add a prediction column at the end. The label of the column is going to be prediction of the partnership. So these are the predictions of yes and no that are going to be done on the basis of the logistic regression model. Let's just click OK and run this. And let's add another node, which is the scorer node, which is going to tell me the different model evaluation metrics like accuracy, precision, recall, true positives, etc. So to do that, I have to ensure that my first column is based on the actual partnership, and the second column is based on the predicted partnership. So ensuring that these correct selections have been made, let's just click OK and execute the scorer node. And when we go to the accuracy statistics tab right here and look at the table view, we can see that all those measures like true positives and false positive, true negative, false negative on the basis of those 15 rows have been calculated. And here is the accuracy of the model, which is like 73% on the test data. And these are the values of precision, recall, sensitivity, specificity, etc. The first portion here gives us the confusion matrix. So this is the confusion matrix based on those 15 rows that we had looked at. And the model evaluation metrics like precision, recall have been calculated on the basis of this confusion matrix. So in this video, we have learned how to build a logistic regression model to predict a binary outcome variable. We have looked at two different variants of doing the same. In the first one, we simply built a model using all the data and finally calculated the coefficients to the odds by using that mathematical formula of e raised to power x. In the second part, we partitioned our data into testing and training set. The training set was used to build the model, and then the test data was provided to that model to come up with predictions, which we later on scored to find the model evaluation metrics. So that will be all for this particular video.